Zdravo! Welcome to the module Industrial Waste Utilization in Civil Engineering. I'd like to present the possibilities of using the industrial waste in sustainable civil engineering. Pollution reduction and minimizing the use of natural resources are the fundamental principles of sustainable construction. Although a new wave of sustainable building materials have emerged recently, concrete will remain in use as a favorite construction material well into the future. But what makes concrete such a great building material? Concrete is durable and flexible. It resists fire, reduces sound transmission and minimizes floor vibration. It is readily available and affordable. And above all, it offers an architect a great deal of freedom in generating complex forms and eye-catching results. For these reasons, concrete plays a part in nearly every significant structure built in the world today. However, the environmental impact of concrete is rather complex. It is bad because making a concrete is connected with huge energy cost and even bigger emission of greenhouse gases. Cement is, of course, the key ingredient of concrete. The cement industry is one of the main producers of carbon dioxide, a very potent greenhouse gas. The CO2 emission from the concrete production is directly proportional to the cement content used in the concrete mix. It is estimated that every ton of Portland cement produced releases nearly a ton of CO2 into the atmosphere. To illustrate the scale of this phenomenon, all the forests in the world are not enough to offset even half the environmental impact of global cement and concrete production. The most important raw materials for making cement are limestone, clay, and marl. Aggregate, which makes up 70 to 80% of concrete mix, is produced from natural rocks. Aggregates are inert, granular materials, such as sand, gravel, or crushed stone that, along with water and Portland cement, are an essential ingredient in concrete. These materials are non-renewable. They are extracted from quarries by blasting or by ripping using heavy machinery. On the other hand, in many cities, industrial waste is an obvious and visible problem. Landfills are located in close vicinity to the cities or even in the suburban areas. Thermal power plants and metallurgical facilities generate huge amounts of industrial waste. Large landfills occupy fields near many cities. Industrial waste sink in harmful chemicals into groundwater and pollute soils. Paradoxically, industrial waste can make concrete and other construction materials more sustainable, and right now you will learn how it is possible. First, let's learn about green concrete. Green concrete is a concrete which uses waste material as at least one of its components, or its production process does not lead to environmental destruction, or it has high performance and life cycle sustainability. Concept of green concrete is not the new one. Researchers now believe that the ancient Romans created concrete that is far more environmentally friendly and durable than modern concrete. Romans used volcanic ash to produce concrete, and now we use industrial waste or byproducts. By replacing cement or aggregate with these materials, a more sustainable concrete can be obtained with lower permeability and higher durability, better resistance to alkali silica reactivity, better resistance to sulfate attack, easier placing and finishing, and of course, better economy, because industrial waste costs less than Portland cement or natural aggregate. The main byproduct of metallurgical processes and thermal power plants are air-cooled and granulated blast furnace slag, steel slag, fly ash, and microsilica. Crystalline blast furnace slag and steel slag are almost inert. They usually have good physical-mechanical properties and can be used as a substitute for natural aggregate in concrete and road constructions. Benefits of aggregate supplements use are ecological, it saves natural resources, waste management is improved. Then economic, lower price compared to natural aggregates, and mechanical properties of final products could be significantly improved. There are, however, some issues, such as lack of experience in slag use by local construction companies, volume instability, which can be eliminated by appropriate weathering procedure, and increased transport costs due to higher density of steel slag compared to natural materials. Fly ash, microsilica, and ground granulated blast furnace slag are used as a cement substitute. Fly ash is the residue of burning coal in thermal power plants. It is so-called pozzolanic material, which means that it does not have any binding properties, but it has the ability to contribute to the strength of concrete through reaction with lime released by cement hydration. Microsilica is a byproduct in arc furnaces for the production of elemental silicon or ferrosilicon alloys. It has great pozzolanic activity and is used as mineral mixture for cement and concrete. Ground granulated blast furnace slag has latent hydraulic properties, which means that it can react only after proper activation. Benefits of cement supplement use are ecological, economic, and durability of concrete structure is improved. Issues are lower early strength of concrete, lack of experience in mineral concrete admixture use by the construction companies, and there is also a fear of potential problems, such as delayed volume expansion, for example. These are the obstacles for wider use of alternative raw materials in the construction industry. So, it is of great importance to encourage construction companies by providing more proofs on their safe and economic use. Currently, there are only few regulatory measures to promote the use of secondary raw materials in the construction industry, so only lower production costs and guaranteed safe use can motivate construction companies to start using these byproducts. Nevertheless, balancing the need for economic growth with sustainability remains one of the most pressing challenges facing the modern construction world. Today, innovators are looking to improve the environmental credentials of concrete. A number of additional recycled pozzolans are currently being tested, and we'll see what improvements these materials will yield. So one thing is for sure: the future of concrete as a fundamental building material is bright. Or perhaps it is better to say the future of concrete is green. Thank you for attending this module.